Hi everyone. In this video I am going to demonstrate how you can perform mediation tests using Stata where the results are reasonably consistent with those that would be produced if you were using Hayes process macro in SPSS or SAS. So in particular we are going to be working from model 4 that's associated with his macro. Now before we get started, I do want to mention that underneath the video description I'm going to include links to the data file that I'm working from in this video presentation. Specifically it will be the Stata data file that I'm going to be working through, so you can download that to follow along during the Stata portion of the presentation. And additionally I will include a link to the do file that I will be working from in this presentation, so you can download that and study the syntax a little bit more closely. So before we get started, what I wanted to do is to review model 4 from his process macro, and this is just the basic mediation triangle. And you can see right here that we have variable x, that's the independent variable in the model, predicting m, which is the mediator, and m predicts y right here. And you'll notice that we have paths that are denoted as A, B, and C prime. So when you are performing the mediation analysis, path A is generated through regressing the mediator onto X, and then paths B and C prime are estimated through a regression of Y onto both the mediator and variable X. So in our demonstrations in this video, we are going to be working with several variables. We have mastery goals, student interest, achievement, and there's also an anxiety variable. So in the first of the demonstrations, we're going to be testing the indirect effect of mastery goals on achievement through the mediator of interest. So in this case, the output is going to incorporate two regression models, basically the regression of interest onto mastery and then also the regression of achievement onto both interest and mastery. The second model that we will test looks like this. So this is also possible with model 4 in the process macro. So in this case we have two mediators of the effect of mastery on achievement. So in this case we have interest and anxiety proposed to mediate the effects of mastery on the achievement variable. So let's begin just by running both of those analyses in SPSS, where we're using the process macro, just to kind of give you a feel for what is being done, and then we will try to replicate, or at least come close to replicating, the same output when using Stata. So we'll go under Analyze and go to Regression and then go down to Process right here, and I'm going to reset this. And so this is the interface, and we are going to put Achieve in the Y variable box, we'll put Mastery in the X variable box, and we'll put Interest in the mediator box. So this is for the first test of the mediation of mastery on achievement via the interest variable. So the model number we would be setting at 4, and then the confidence interval defaults at 95%, so that's it right there. The default number of bootstrap samples right now is set at 5,000. I'm going to set this a little lower just to take a little bit less time to run the analysis. So we'll click on OK, and it takes a few seconds to run because it's performing the bootstrap. So you'll see in our output, first off, the R-square value for the model 1 is given. You can see this is a regression of interest onto the mastery variable. So there is our regression slope of 0.7701. We have statistical significance. So you can see basically that mastery goals is a significant predictor of the proposed mediator interest. Then you can see that we have the second model where we have achievement regressed onto both mastery goals and interest right here. So the regression slope for mastery, this is basically the C prime path, is 0.3613, and we have statistical significance. And then the slope for the effect of interest on achieve is also statistically significant over here, so it's positive and statistically significant. So, and again, the R-squared values are actually quite large for both of these models. Now, as we scroll down, you'll see that we have our indirect effect that's given right here. So this is computed as a product of path A, which is mastery to interest, and path B, which is the path from interest to the achieved variable. So that's the product. This is the unstandardized indirect effect. And then you can see that we have our confidence interval that was created utilizing bootstrapping. So basically what happened is that we generated 1,000 bootstrap samples for and then from each of those samples both regressions were run, the indirect effects were computed, and then that leaves us with a sampling distribution of the indirect effects, and then from that we are generating the confidence interval that you see right here. So the lower bound is 0.0576, the upper bound is 0.2739. So if 0 falls between the lower and the upper bound, we would infer that the population indirect effect is 0. If 0 falls outside the lower and the upper bound, then we would infer that the population indirect effect is non-zero. So now let's quickly run the second model where we have anxiety serving as as an additional mediator. So I'll move anxiety to this box. And so hopefully by now you see that one of the limitations when we're using process is that we cannot incorporate multiple x variables that are being proposed to have mediated effects on y. So let's say that I wanted to include performance goals as another variable whose effects I would want to test as being mediated through interest and anxiety. I couldn't do that in this particular through this option. So that is one of the limitations of the process macro. So we can only test for mediation involving one x variable as in this particular case right here. So nevertheless, we'll go ahead and click on OK, leaving the previous defaults. And now when we generate our results, you'll see that up here we have our interest variable. Again, this is regressed onto the mastery variable. So that's that path A, if you will, that we were talking about. And so there's our slope and significance level. It's exactly the same as what we had before. When we scroll down, you will also see the path from mastery goals to anxiety given right here. So you can see that slope is negative. It is also statistically significant though. The last regression is of achievement being regressed onto mastery, interest, and anxiety. So in this case right here, you see that the paths from mastery and interest are both positive and statistically significant, whereas the path from anxiety to achievement is negative, but it is not statistically significant, as you can see right here. Then when we scroll down a little bit further, you're going to see first off, we have the indirect effects broken down into specific and total indirect effect. So in other words, what you'll see right here, this is the indirect effect of mastery on achievement via the interest variable, and then we have the indirect effect of mastery on achievement via the anxiety variable. So these are referred to as specific indirect effects, and both of those are tested for statistical significance using our confidence interval. So you can see the specific indirect effect of mastery on achievement through interest is statistically significant, whereas the indirect effect of mastery on achievement through anxiety is not statistically significant because 0 falls between the lower and the upper bound of the confidence interval. And then obviously if we take these two specific indirect effects and sum them, that produces what's referred to as the total indirect effect. And so right here we can look at this if we wanted to test where the total indirect effect is statistically significant. And clearly 0 does not fall between the lower and the upper bound, so that would indicate again that mastery is exhibiting an that the effect of mastery on achievement through the mediators as a set is statistically significant. So now let's go ahead and open up Stata and run our analysis using that program. So here we have Stata opened up, and the variables have been and the data have been imported into Stata. So we're going to run both of our analyses and generate our indirect effects and bootstrap test results. So I'm going to go over here to click on the do file icon right here, and we'll start off by testing that first model. So in this case, I'll type in SEM, and inside the first parenthesis, I'm going to type in the name of the proposed mediator, which will be the interest variable. I'm going to type a less than sign and then a hyphen, which produces an arrow, and then I'm going to type in mastery right here. So we have mastery predicting interest. Then I'm going to start another parenthesis, and I'm going to type in the name of the dependent variable in our model, basically our y variable in the model. I'm going to type in achieve, and then have an arrow pointing from both mastery and interest. Okay, so this first one right here, this is going to generate my path A, and then this one right here is going to generate both my paths B and C prime. And then finally, at the end, I'm going to type in a comma, and I'm just going to go ahead and include the option no caps latent. And I'm not going to spend any time on that, but oftentimes it's a good idea when you're working with nothing but observed variables to include this option in your code. So now, just really quickly, if I highlight all of this and run it, you'll see that I get my basic output. So you'll notice that I get basically the effect of mastery on interest. This is the regression slope right here. You'll see it's 0.7701, and you can see it's statistically significant. This is very consistent with the process output that we saw before. I do want to mention that the coefficient, the estimates in process are generated using least squares regression. In this case, we're using maximum likelihood estimation. But nevertheless, the results are very similar. You'll also see then that the path from interest to achievement, this is our path B right here. This is the coefficient, and we have it statistically significant. Once again, these results are very consistent with what we had before with process. And then between mastery and achievement, our path C, which is given right here, and it's statistically significant. So now what we're going to do is generate the indirect effect and our confidence interval, our bootstrap confidence interval for that indirect effect to test for statistical significance. So the way that we will do this is we're going to write a small program. I'm going to type in program right here, and I'm going to call it indirect. So right here we're going to type the name of whatever your program name is. So again, I'm calling it indirect, then comma, and then I'm going to type in our class right here. And next what I'll do is I am going to take pretty much everything I wrote up here, and I'm going to include this on the next line right here. And then we are going to type in return, then scalar, and then the name of whatever name I want to call the indirect effect. So I'll just call this IE, and then we'll type in equals. Now really quickly, what we're going to be doing next is relying on labels related to the parameters associated with our model. So just show you really quickly, we'll go down to the command line right here, and I'm going to type in SEM, comma, and then COEF legend, and this is the coefficient legend associated with that path model that we are going to be running, or that we've already run. And you'll notice that we have the legend that's given right here, and you'll notice that we have the label for the path from mastery to interest is this right here. So it's the underscore B, and then inside the parenthesis we have the name of our mediator, interest, colon, and then mastery right here. So we can actually take this right here, this code, and I'm going to copy it and paste it into the do file right here. So I could have just as easily typed it, but just in the interest of reducing the likelihood of error, that's very easy to do. Next, what I will do is I will type in that I will identify the path from interest to achievement. So this is that path right here. So I'm going to take this label and add it to my do file code, but first I'm going to type in asterisk and then add that. So now you can see it says IE is equal to underscore B, and inside the brackets we have interest colon mastery. Then at the end of the bracket I then have the asterisk right here, then underscore B, and inside the brackets I've got achieve colon interest right here, and then in bracket. Then I'll type in end to end this program, and next what we'll do is we will type in bootstrap, then R, and inside parenthesis I'm going to type in the name of the indirect effect that I've called it up here, which is IE. So that's it right there. Next we'll type a comma, and then we will use the option reps right here for the number of bootstrap samples, and inside parenthesis I'm going to go ahead and just use 100 for the number of bootstrap replications. Then follow that up with a colon, and then we're going to use the name of the program up here, which is indirect. So I will type that in right there. Whoops, excuse me. I will type in indirect right here, which again is the name of the program, and now we are ready to perform our bootstrapping. So I'll highlight all of this that you see right here and click on execute selection, and so then it goes through the process of generating the bootstrap process, or it's going through the bootstrap process. So now you can see I've got 100 bootstrap replications, the indirect effect, which is computed right here, and then we have a confidence interval that is produced right here. So basically 0 does not fall between the lower and the upper bound, and that would lead us to infer that the indirect effect is statistically significant. Now, if it's the case that we want to obtain a percentile or bias corrected confidence interval, that can be done very easily too with the additional syntax right here. So what I'm going to do now is I'm going to go to the next line and type in the estat, that's the post estimation command, bootstrap, then comma, and then all. And so now when I highlight all of this and run it, you can see that now again there's our indirect effect, and now we have, this is the previous normal confidence interval that was produced above. Then we have the percentile bootstrap right here, and then also the bias corrected confidence interval right here. And just so you know, my understanding is that with process he's using the percentile bootstrap confidence intervals. So that's what these are right here, and you can see that in our results those are actually the most consistent with what we have right here with our percentile confidence interval. Okay, so now let's rerun our analysis with the anxiety variable also included as a mediator. So now what I'm going to do is just add to our do file, and I'm just going to go ahead and type in again SEM for our command, then interest being predicted by mastery, and then we'll type in anxiety, which is predicted by mastery, and then we're going to type in achieve, which is predicted by mastery, interest, and anxiety. And you can see that the line is starting to run a little bit long. And so that can, if we want this to wrap around, we can easily do so by typing in a comma and then 3 forward slashes right here, and go to our next line, and then right here we'll just go ahead and use the no caps latent option that I was kind of mentioning before. So really quickly, just running this analysis, we'll click on execute selection, and then so there it is right there. So this again contains our regression coefficients that's very consistent with what we saw before when we ran that second model with anxiety included as a mediator through the process macro. So again, there's our mastery to interest coefficient, it's statistically significant. Mastery to anxiety, there's the coefficient and it's statistically significant. And then when we look at interest, anxiety, and mastery, the direct effects on achievement, you can see that the direct effect of anxiety on achievement is not statistically significant, whereas the other effects are statistically significant. So nevertheless, let's go ahead and go back and write a quick program for capturing the indirect effects and testing them in our model. So I'll type in program, and now I'm going to create a new name for this. I'll just call this indirect 2, and then comma, and then we'll type our class. So again, the indirect 2 is just an arbitrary name that I've created. So now we'll type in SEM. And in fact, what I'll do is I'll just go ahead and I'm just going to copy all of this from above and paste it in down here just to kind of expedite things. Then I'm going to type in return scalar, and then I'm going to type in IE, and well, actually I'm going to type in SIE1 for specific indirect effect, and this will reflect the specific indirect effect of mastery on achievement through interest. So now I will type in equals, and then basically I'm just going to take the same information that we had above right up here. It's a lot easier than everything we had done before. So I'm just going to put that in for that one. Then I'm going to say return scalar SIE2 is equal to, and if I paste this in and just make a couple of changes, we have anxiety as the second mediator, so I'll just type that in right here. Where mastery is predicting anxiety, and then we'll have anxiety predicting achieve right here. Okay, and then finally, if I want the total indirect effect, I can request that as well. Return scalar, then I'll just call this TIE for total indirect effect. And so in this particular case, the total indirect effect is the sum of this effect right here and this indirect effect right here. So very easily I can just kind of highlight this and copy it, paste it in right here, then say plus, and then I am going to actually, since this is going to wrap around, I'll just include a space, 3 forward slashes, and then I'll take this next line right here starting at the underscore B and paste it in down here, and then type go to the next line and type N. So that's the end of the program. Then I'll type in bootstrap and then R, and inside that parenthesis I will type in SIE1, and that's all in caps by the way, then R SIE2, and then R TIE for the total indirect effect right there. We'll type in reps and then follow that up with, again, we're just going to use 100 bootstrap resamples in this case. We'll put colon and then the name of this program, which is called Indirect 2. So I'll type in Indirect 2, and now we are ready to go. So I'm going to highlight all of this right here and click on Execute. And so now it's performing the bootstrapping. So now we have all three effects that are reflected in this table. So we have the first specific indirect effect right here. So that's the SIE1. The second specific indirect effect through anxiety, there's the SIE2. And then the total indirect effect, which is reflected right here. And so we can see we have our normal based confidence intervals. So the specific indirect effect through mastery goals is statistically significant because 0 does not fall between the lower and the upper bound. The specific indirect effect through anxiety would not be deemed statistically significant. So that first one is significant, the second one through anxiety is not significant, and then our total indirect effect would be deemed as statistically significant right here. So once again, if we want to generate those alternative confidence intervals, the percentile and bias corrected confidence intervals, we can easily do that by just going back into our do file editor right here, and I'm going to type in estat, and then we will type in bootstrap, comma, and then all, and then when we highlight all of this and execute it, we get all three of our confidence intervals associated with the specific indirect effects and then also the total indirect effect. Okay, so that pretty well wraps up this video presentation. As I said before, you can download the data at the link that will be provided underneath the video description, and also I'm going to include that link to the do file that I just worked up as I was going through this presentation, so you can download that do file to study that syntax a little bit more. So I appreciate you watching.